let's get back to the new chapter. We're going to begin a new lesson. The name of the lesson is Applications of Trigonometry. In the previous lesson, we have done the trigonometric ratios. Now we are going to use them to find the heights, the distances of different objects. Alright, but before we begin the sums, let's have a clue about the basic concepts related to this particular lesson. As you can see, a right angle triangle drawn here. At point A, I see the observer. Now suppose if the observer stands here and he looks at the tower from here. Now what is termed as line of sight? Line of sight is a line drawn from the eye of an observer. Now if the observer is on the ground, then the line which is drawn from the eye of an observer to the point where the object is viewed, that is termed as line of sight. Now this observer can be either on the ground or also above the ground, somewhere on top, and the object is under the horizontal line here. Second, what is angle of elevation? Now, if the object under observation is above the horizontal line here, it's above the horizontal line, right? Now, if the observer is standing on the ground, then the horizontal line is this one, and the object is above it. So, the angle which is formed between the line of sight and the horizontal for an observer on the ground is the angle of elevation E, this one. What is angle of depression? If the object is below the horizontal level, now suppose if the object is laid here and the observer is above, it means, now see, the horizontal line is this one, the observer is on top at a height, the object is at the bottom. So, the angle which is formed between the line of sight and the horizontal is termed as angle of depression. Now let's remember one thing, as we have done this concept in 9th standard, that whenever transversal cutting two parallel lines, a pair of alternate angles are formed. So with this rule, if we follow that, we find that angle of elevation has a measure always equal to angle of depression. So we'll be utilizing these basic concepts, and later on we'll also utilize the ratio of sine, cos as well as tan, or sometimes we may use cosec, sec or cot while solving the sums which are related to the topic of applications of trigonometry. So in the next session we begin exercise 9.1. Now we are going to start question number 1 of the new lesson, exercise 9.1. I'll be explaining the questions. I'll take the questions and explain with the help of a diagram, and then we'll solve the sum to get the answer. So what's given in the question? We are given that a circus artist, he starts climbing from here, is climbing a 20-meter long rope which is tightly stretched, okay, and tied from the top of a vertical pole. As you can see the pole on the right hand corner here, the top of the vertical pole to the ground. So this rope is tied to the top of the vertical pole, and the circus artist climbs from here. Okay, then what is given to us? First of all, we have to find the height of the pole, and if the angle made by the rope, as you can see, this is the rope, the angle made by the rope with the ground here, this is the level of ground, that angle is 30 degrees. Alright, so we will start the sum with the values given first. What all is given to us? So we will write given. We will write AC, we will write here length of rope is equal to 20 meters. So let's mark it so that you can read. Let's mark it clearly. Okay. What else is given to us? Angle ACB. The angle between the rope and the ground is given to us. ACB is equal to 30 degrees. The measure of it is given. We have to find. What do we have to find? We have to find the height of the pole. That is, AB is to be found. So in bracket you can write height of the pole. Height of the pole. Now, if we compare this triangle, we are supposed to find the altitude. The value of the hypotenuse is given to us. So which ratio do we think can be utilized to find the altitude when the hypo and the theta is given to us? It is the value of sine theta. So replacing, now we start the solution of the sum. Okay, replacing the values from the right angle triangle in the trigonometric ratio, we have sine, we'll write this first, sine theta is equal to, the value of altitude is AB, upon the value of hypo is AC. Now replacing the value of theta from the diagram here, we have the value of sine 30 degrees is equal to value of AB is now known to us. We have to find the value of AC is 20. Now, in the previous chapter I had taught you how to find the value of sine, cos and tan of 30 degrees. So if we really remember, then we know that the value of sine 30 is half, which is equal to AB by 20. Interchanging the place of the values, you get AB is equal to 20 upon 2. On cancellation, you get the answer as 10 meters. So in the last line, you will write that the length of the pole AB is 10 meters. Now, moving to question number 2, I dictate the question and then explain the concept from the diagram. A tree breaks due to a storm. You can see the whole tree is drawn there. It's broken from that section. So you can see the section bent from there. And you can see the fallen tree here. Okay. Now, a tree breaks due to a storm and the broken part bends. So that the top of the tree, you can see, after it broke, the top of the tree lies here. The top of the tree touches the ground. It makes an angle of 30 degrees. Okay, with the ground. Now, the distance, it is also given in question, the distance between the foot of the tree to the point where the top of the tree touches the ground, the distance of it is 8 meters. And what are we supposed to find? We are supposed to find the height of the tree. So if you see carefully in this triangle, then in this triangle, half the height is from A to B and the other half is from B to D in the triangle. Okay, so first we need to find the altitude and then we need to find the hypotenuse to get the total height of the tree, that is equivalent to AC. So let's begin the sum. We'll write first what is given to us. We are given in the question. First of all, we are given the value of AD. Now what is AD? You can write here the distance from where the top of tree touches the ground to the bottom of the tree or the foot of the tree is equal to 8 meters. The angle formed by the top of the tree to the ground, that is angle angle BDA is equal to 30 degrees is given to us. Okay, now we have to find the height of total tree. It means first we'll write here to find. So first we'll find the measurement of AB according to this triangle. We'll find the measurement of AB and then we'll find the measurement of BD, because this is the half of the tree that is fallen on the ground, and then we'll add both the measures, okay, to find the total height of the tree. Now for this one, if you see in the triangle, then this is the altitude we have to find and we are given the value of the base is given to us. So which ratio do we think can be utilized to find the value of this when the adjacent side is given to us? The value is tan theta. So we start the solution here. Solution is tan theta or tan of angle BDA is equal to the side AB upon AD. Now let's replace this theta with the values and also the other values with the numbers that are given to us. Tan 30 is equal to value of AB is not known to us from the triangle. The value of AD is 8 meters. Now, according to trigonometric table, the value, if you have memorized properly, then the value of tan 30 is equivalent to 1 by root 3, which is equal to AB by 8. Okay, so changing the place of this value, you get the value as, therefore, the measurement of AB from here till here, this portion of the tree is equal to 8 upon root 3 meters. This is a one section, only half the measure of the tree which is taken. If you see, the other half of the tree has fallen down here. Okay, so utilizing this value to find the hypotenuse. Now we know that this value is the adjacent. So the trigonometric ratio utilized to find the value of the hypo when adjacent is given to us is cos theta. So I can rewrite as cos theta is equal to AD upon the value of hypo, that is equal to BD. Okay, now replacing the values for this, I get cos 30 degrees is equal to AD upon BD. Okay, Now what is the value of cos 30 degrees? Now the value of cos 30 degrees is equal to under root 3 by 2. Implies that under root 3 by 2 is equal to, do I know the value of AD? Yes, it is given 8 upon. Do I know the value of BD? No, I have to find that. So I will write it as it is. Interchanging the values of all the values which are given here, you get BD is equal to 8 multiplied by 2 upon root 3, which is equal to 16 and 16 by root 3 meters. Now if you see that this is the measurement of half the portion of tree AB, this is the measurement of the other half of tree BD, but we are asked to find the total height of the tree. So to find the total height of the tree, I am going to add both of them, AB plus BD. So I get the value as, I write first total height of tree is equal to 8 upon root 3 plus 16 upon root 3. As I can see, root 3 is common in denominators, so the LCM leads to root 3. I add both the values in numerator, I get 24 by root 3, and I further rationalize it. 24 root 3 upon root 3 to root 3, so I get here 24 root 3 upon 3. On cancelling both these, I get the answer as 8 root 3 meters. So in the last line, you write the answer as the total height of the tree is 8 root 3 meters. Okay, now moving to question number 3 of exercise 9.1. I already drawn the diagrams for you people. So I'll take the question, explain the concept was given to us. A contractor plans to install 2 slides. You can see slide 1 and slide 2 for both. 2 slides for the children to play in the park. Now for the children below age of 5 years, okay, she prefers to have a slide whose top, as you can see, the top of the slide, okay, is at a height of 1.5 meter from the ground. Okay, it is inclined at an angle of 30 to the ground. And the second one, whereas for the elder children, the height of the slide, she wants to have a steep slide at a height of, as you can see, 3 meters from the ground. The top of the slide is at a height of 3 meters from the ground, and the angle of elevation made by the slide to the ground is 60. Now what are we supposed to do? What should be the length of slide in each case? We are asked to find the length of the slide for the younger children and for the length of the slide for the elder children. So let's find out. First we are going to write what is given to us. In the first sum, we are provided the values of, given is what? We are given the height, that is AB of the height of the slide from the ground. AB is given to us. We are given the measure of theta, that is angle ACB is given to us. ACB is equal to 30 degrees. And we have to find AC. So you can write to find the length of the slide, that is AC is equal to question mark. Similarly, we have here on the right hand side, we are given, what are we given? The height of the slide from the ground. So we are given the measurement of DE, which is equal to 3 meters. We are also given the measurement of theta, that is angle DFE is given to us as 60 degrees, and we have to find the length of the slide, that is DF is to be found. So if you see, in both the cases, we are given the altitude. The altitude is given to us, and we are asked to find the measurement of the hypotenuse. So if you see, the very first trigonometric ratio can be utilized to find the hypotenuse when the theta is given to us and the altitude is given to us. So utilizing that trigonometric ratio for both the parts of the sum. Let's solve it. Sin theta is equal to, the measure of altitude is AB upon hypotenuse is AC. So let's write the measurement. Sin of 30 degrees is equal to, measurement of AB is 1.5 upon AC. Similarly, you can write it here as well. Okay, sin of 60 degrees is equal to the altitude, that is equal to DE upon hypotenuse, that is equal to DF. Okay, now replacing the value of sin 30, so we can see the value of sin 30 is 1 by 2, which is equal to 1.5 upon AC. Okay, now interchanging the places of these, you get AC is equal to 1.5 into 2, that is equal to 3 meters. So we have got the measure of first slide, that is equal to 3 meters. Now replacing the value of sine 60. So the value of sine 60 here is under root 3 by 2, which is equal to, what is the value of DE? That is equal to 3 meters upon TF. Interchanging the places of all the values here, we get df is equal to 3 multiplied by 2 upon under root 3. So you get the value as 6 by root 3, and rationalizing it further, that is multiplying the values by root 3 in numerator denominator, you get the answer as 6 root 3 upon 3. On cancellation, you get the answer as 2 root 3 meters. So this is the value for the longer slide, and for the smaller slide the value is 3 meters. Now in question number 4 from exercise 9.1, I drawn the diagram for you to understand it. I want to explain it to you along with dictating it. Now the angle of elevation, you can see angle of elevation here. The angle of elevation of the top of a tower, you can see the top of a tower there, okay, from a point on the ground. Now this point on the ground is 30 meters away from the foot of the tower. Okay, now this angle of elevation is 30 degrees. We have to find the height of the tower, this one. So what is given to us? We are given the value of the adjacent, we are given the value of theta, we have to find the value of the altitude. Now according to the trigonometric formula that we see, trigonometric ratio, we find that tan theta is the ratio we can take to find the value of altitude where the adjacent is given to us. So before that, we write what is given to us. Okay, we are given that distance BC, that is distance of a point from the foot of tower, is given to us, that is equal to 30 meters. The measurement of angle ACB, that is the angle of elevation, is 30 degrees. What do we have to find? We have to find the height of the tower, which is equal to AB. So now we start a solution. Now, owing to the given values in the question, we will compare these values with the trigonometric ratio and utilize the right ratio. Tan theta is equal to, see the ratio is altitude upon adjacent. For theta, the altitude is AB upon adjacent is BC. So let's replace the value. Tan 30 degrees is equal to, the value of AB is not known to us, value of BC is 30 meters. Now, in the previous chapter, we have done the values of sine, cos and tan of 30 degrees. So the value of tan 30 is equal to 1 upon root 3, which is equal to AB upon 30 meters. So cross multiplying these values and taking known values and unknown values on the other side, we are left with AB is equal to 30 upon root 3. Can we rationalize it? Yes, we can rationalize this value. By multiplying the numerator and denominator by root 3, we get the answer as 30 root 3 upon root 3 root 3. Cancelling this, we get the answer as 10 root 3 meters. So in the last slide, you will write that the height of the tower is 10 root 3 meters. Now in question number 5 of exercise 9.1, what are we given? As you can see, a kite flying. Okay, so let's see what's given to us. A kite is flying at a height of 60 meters above the ground. You can see this height, 60 meters above the ground. The spring attached, this spring which is attached to the kite, is temporarily tied to a point on the ground. Now, the inclination of the spring, that is the angle of elevation of the spring, is 60 to the ground, as you can see. Now, what are we supposed to find? We have to find the length of the string. Okay, it means that there is no slack. Now, slack means the string is tight. Okay, when the kite is flying at great speed in the air. Alright, so what are we supposed to do here? Now, comparing the values which are given to us in this triangle and watching the trigonometric ratios. What is given to us? We are given the altitude, we are given theta, we have to find the hypotenuse. So we can see that we have to use this trigonometric ratio and none of those. Now first we will write what is given to us. Now if you see what's given, first of all we are given the measurement of the angle. ACB is equal to 60 degrees. Okay, the height of the kite from the ground, that is measurement AB is given as 60 meters. What are we supposed to find? So we'll write to find length of the string, that is AC. Now utilizing the first trigonometric ratio, now we'll start the solution of this sum. We'll have sin theta is equal to, what is the measure of altitude? AB upon hypotenuse AC. Now replacing the values in this formula from the values given to us, we have sin 60 is equal to AB upon, is AB given to us? Yes, it is. So let's write 60 upon the measurement of AC. Now in the previous lesson, in the trigonometric table, I told you earlier that the value of sin 60 is root 3 by 2, which is equal to 60 upon AC. Now interchanging the place of these values, all the values, we get AC is equal to 60 multiplied by 2 upon root 3, which leads to 120 upon root 3. Now as we have a number with a square root at the bottom, we will rationalize and we will land upon the answer as 120 root 3 upon 3. Cancelling these two values, you get the answer as AC is equal to 40 root 3 meters. So in the last line, you will write the answer as the length of the string is 40 root 3 meters.